Welcome back to this learning series on Rust. Every programming language has a set of basics that show up in almost every program. These include how you store values, what kind of values exist, how you write functions, and how you make decisions and repeat work within your programs. In this video, we're going to cover how those basics work in Rust. They're not difficult to understand, but a few of them behave differently from other languages, so it is worth taking some time to actually see how it works. We're going to take a look at variables and mutability. We'll also discuss some core data types in Rust, how we can actually declare functions in Rust, and the control flow keywords, such as if, loop, while, and for. I've got a basic program here that will run through each idea so we can see how it works in action. Let's start with variables. In Rust, you can create a variable with the let keyword, like so. Now, the first surprise for newcomers to Rust is that by default, this variable we've just declared is immutable. Once it has a value, you cannot change it. If you try, the compiler stops you. That sounds restrictive, but it does remove a whole category of bugs, and it makes our code easier to reason about. Let's see what happens if we try to change the value of x. And now if we use cargo run, we see that we get a compile error because we've tried to change the value of an immutable variable. I'll clear my terminal and get rid of this variable here. There is a way that we can actually change the value of our variables. We can do so by using the mut keyword, or mutable. So if I try and compile this program again, I'll get a warning saying that I'm not using this variable y, but there's no error because we can change the value of that variable because it's mutable. There's also a way that we can actually declare constants, and these variables are for values that are fixed at compile time and never change. By convention, we write them in all capitals, like so. Now, Rust has a special feature that looks like mutation, but is not, and that's called shadowing. Essentially, this means you're allowed to declare a new variable with the same name as an old one, like so. So the first gaps variable is just text, and the second gaps variable is just a number. We reuse the name, and we even change the type. This is different from mut or mutable variables, which keeps the same type or data type and the same variable. What shadowing does is it creates a brand new variable each time, and this is handy when we want to transform a value through different stages of our program. Now let's talk about data types in Rust. Rust is a statically typed language, which means that every value has a type that is known at compile time. Most of the time, the compiler infers the type for you, but sometimes it needs a little help, and you can annotate the type with a colon. For example, now the scalar types are the simple ones, and these are things like integers like i32 and u32, floating point numbers like f64, the Boolean type true and false, and the character type, which holds a single Unicode character. There are also two compound types worth knowing about in Rust. The first is a tuple, which groups a fixed number of values that can have different types, like so. Now with tuples, we can pull them apart with destructuring, as we are doing on the second line. Or we can reach in position with a dot and an index. The other type of compound type that we should know about at this point is an array, which is a fixed length list where every element has the same type, like so. Now the thing to note about arrays is they have a fixed size. If you want to work with lists that grow over time, we reach for something called a vector. We'll cover these in a later episode. Now let's talk about functions. We got introduced to our first function in the first lesson when we talked about the main function, which is the entry point to any program in Rust. Functions are declared with the keyword fn. Now Rust uses snake case for names, so lowercase words joined by an underscore. And every parameter in a function must have a type annotation. Take a look at this one, for example. So the arrow in this function shows the return type. Now look closely at the body. This is just a plus b. We're not doing anything special in this function. And there's also no return keyword and no semicolon. In Rust, the last expression in a function is its return value. This is the difference between a statement and an expression. A statement does something and returns nothing. An expression evaluates to a value. Leaving the semicolon off in the last line just means that we are handing this value back. If we went and added a semicolon, we turn it into a statement, and this function would return nothing, which is a common mistake that people do when they're first working with Rust. Finally, let's take a look at control flow. Let's start with if. Now the if keyword works as you would expect. So if something is true, do this, else do that. But in Rust we have a little twist. In Rust, if is also an expression, so it can produce a value that you can assign. For example, so if true, number is going to be 5, else number is going to be 6. Now the for loop will iterate over a range or a collection, like so. Now this range with the equal sign, got a plus sign there, that's not good, we'll put an equal sign there, just means that it is inclusive. So it's going to count 1 through to 5. There is also the while loop, which is used for looping while the condition holds, and loop, which repeats until you break out of it. Loop has its own twist. We can use the break keyword to return a value, like so. So loop is not only an infinitive loop, but can also compute a result and hand it back when it breaks. So let's go back and recap. Variables are immutable until you add the mute keyword. Shadowing lets you reuse a name and even change the type of a variable. Every variable has a type. Functions can return their last expression, as we're doing so here, and the if and loop expressions are expressions that produce values. Before moving on, check that you can do some of the following things that we covered in this lesson. First off, explain why shadowing is not the same as mute. Then make sure you can write a function with type parameters and return a value. And then have a play around with some loops. So use if as an expression and then use loop to return a value. In the next video, we're going to actually put these basics to work by building a very small program, a game of rock, paper, scissors, which will introduce reading input using external libraries and also the match keyword. If you like this video, give it a like. If you want to see more videos on Rust and follow the series, don't forget to subscribe. And if you have any questions, please put them in the comments. We'll see you in the next one where we'll be building our rock, paper, scissors game.